Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you so much for joining us on the Space Nuts podcast. Andrew Dunkley here, and joining me as always, Professor Fred Watson. Hello, Fred.
Hi, Andrew. How are you doing?
I'm well, thank you. Yes, been a tumultuous week since episode 150. It's, went ahead in leaps and bounds. A lot of response to that episode, so very, very pleasing.
Yeah, thanks everybody for getting in touch, and thanks for listening.
Yeah, now we've got twice as many questions to get through as we had before, so I might never appeal for questions again because we got inundated. Quite a few of them turned up after we recorded, so we're going to work our way through them. We're going to bump off 3 today, which we'll get to shortly. I might as well talk about what they're asking us about. We've had a question about Stephen Hawking's alien warning, which is a good question. We're also going to investigate, this was more of a comment, but you, knowing what you do know about telescopes, Fred, will be able to answer add to Michael's question about spider silk in telescopes. And we are going to do a bit of a movie review. We'll talk about the movie Gravity, which you and I have both seen. I thoroughly enjoyed that film. And you could call it science fiction, but it sort of borders on reality because some of the things that were portrayed in it are indeed happening as we speak. We're also going to look at today a very hungry black hole. This thing is not only eating a star, it is I'm going to try and think of a delightful way of saying that it is vomiting plasma. And not very delightful at all. And a new theory about the creation of our only moon. So we'll get all that done in episode 151 of Space Nuts. And I've got a bit of news for you to share shortly too. But first, a very hungry black hole. This thing's a fairly large black hole, and it's acting in a way that would get it kicked out of a restaurant.
Actually, look, you can stick with your vomit analogy if you like, but I prefer the lawn sprinkler model.
Oh, well, yeah, that would probably be closer to the fact.
Yeah. So make of all that what you will. But yeah, that's kind of quite a nice, a nice notion. So what is this? It is an object which rejoices in the name of V404 Cygni. And that tells you, first of all, that the V means it's a variable star, because that's how variable stars are nominated. It's actually one of the ways. There's a number of ways. But also that it's in the constellation of Cygnus, which is a Northern Hemisphere constellation. We catch glimpses of it from here in the south, but it's overhead in the mid latitudes of the Northern Hemisphere. It's known to have a black hole in orbit around a star, and the star is leaching material onto the black hole, basically. And what that means, because they're close enough together that the envelope of the star is being pulled off into the black hole's accretion disk, the technical term for that swirling disk of material orbiting around the black hole, whose inner edge is basically being sucked in because it's going at basically more than the speed of light. It's hurling in. No, that's a throwaway line, which is incorrect. It's approaching the speed of light. It's zooming in through the event horizon. And it's because of the energy that phenomenon stirs up in the accretion disk that we see a number of things. One is we actually get radio emission from the accretion disk itself, and that's how many black holes have been found. But the strong magnetism of a black hole has this curious effect of taking some of that material that doesn't get sucked up into the black hole itself and squirting it out vertically, if I can put it that way, at right angles to the accretion disk. So what you've got is jets of material coming from the north and south pole of the black hole. And that's a phenomenon that's, once again, well recognized. These jets are once again, at very, very high speeds, a significant fraction of the speed of light, very energetic. They emit X-rays as well as radio waves. But it's in radio waves that the observations that I want to talk about have been made. And we have seen observations in the past of black holes spewing out blobs of material from their northern and southern poles, their rotation axes. But this one is a bit different. And it comes about because the plane of the orbit in which the other star of the binary pair orbits the black hole. So you've got a black hole, star going around it, and that orbits in a plane. That plane is slightly different from the rotation axis of the black hole. So the rotation axis of the black hole is tilted slightly. And that produces an effect which we call precession. Precession is a fancy name for something we've all seen. It's the effect when you spin a spinning top, you see it rotating, but you also see it wobbling around as well. And
so it sort of wobbles on its axis while it spins.
Yes, that's right. Yeah, and that's called precession. The Earth does that actually. It wobbles around once in 26,000 years. Put that in your diary as well.
Okay.
Yeah. So, but this thing wobbles on a much shorter time scale, a matter of hours rather than thousands of years. In fact, it might even be minutes thinking about it. So a little bit about the black hole itself. It's a 9 solar mass black hole, quite a modest one in a way. That's at the lower edge of what we call stellar mass black holes. It's about 8,000 light years from the Earth, and has now been observed with an array of telescopes, a little bit like the Event Horizon Array that we've talked about before, that actually gave us that image of a black hole. The array of telescopes included ones here in Australia. Actually, I should just check that. I beg your pardon, it's not. They are all across the USA.
Okay.
So it includes things like the Very Large Baseline Array, which is in New Mexico. I visited there. It's quite stunning. I think you might have done as well, Andrew, have you?
Can't remember. But you know what? It's about time that the Americans did something astronomical. I mean,
look, they're doing pretty well, I can tell you.
They are.
10 radio telescopes across the US, but there is Australian participation in the project. That's what was confusing me there. And they've imaged the blobs of material that are coming from the poles of the black hole. And because of this funny precessional rotation, what you get is not a straight jet of blobs of material. You get a corkscrew shape, which is actually as though you take a cone and you put the blobs of material on the surface of the cone as they're heading outwards from the black hole. It's exactly what you'd expect from precession, and it is. I think what they did was they did 100 or so radio images and then stitched them together to make a movie. To pinch the words of my colleague Janelle Whirl on the ABC's science website, they stitched them together. Yeah. And that's some great way. So you've got a movie that shows these blobs of material coming off. It's not hard to find on the web. Well worth a look. The V404 Cygni black hole jets.
And where does this plasma vomit go?
It basically gets dissipated into space. So it sort of charges out. It interacts with something called the interstellar medium, which is the very low level rarefied gas in between the stars. And it plows into that. And often you can see the effect of that, particularly with very energetic galaxy supermassive black holes. You see jets coming out of them, and then just like a cloud at the end where they've piled into the intergalactic medium in this case, and this usually it's X-ray emission that you're seeing. So they grind to a halt eventually, but of course because they're going at a significant fraction of the speed of light, that takes a little while.
Yeah. Okay. Now, just one more point, because I'm trying to anticipate potential questions from things we discuss. And at the very beginning, you referred to V404 Cygni, the variable star. Someone, and at this time it'll be me, is going to ask, what is a variable star?
Oh, good. Yeah, thank you for that, Andrew, because we use these words glibly and they're not all that obvious when you haven't thought about it. But a variable star is very simple. It's a star that varies in brightness. And, you know, they were much studied in the 19th century. People categorized them. They realized that once astronomers, once astronomers could actually reasonably accurately measure the brightness of stars, and you can do it actually with visual methods, with visual telescopes. You don't need sensitive electronics or anything. It was really in the 1880s, people started doing it photographically, which was more reliable. But as soon as people did start measuring the brightness of stars, we realized that quite a number of them actually go up and down in brightness, some of them by very dramatic amounts. There's a star called Eta Carini, for example, which was virtually invisible for decades or centuries, and then in the 1840s became the second brightest star in the sky. Now has faded away. It's still visible to the naked eye, goes over our heads once a day in Australia, and is actually the most likely candidate for the next supernova in our own galaxy. It's very unstable. Okay. But yeah, variable stars simply vary in brightness.
And that's because of their waning fuel, or
all kinds of different phenomena. There are several different reasons. The simplest to understand is what we call eclipsing binaries. If you've got two stars together, which you can't see as two stars separately because they're so far away, one passes in front of another, it will cause a change in the brightness of the pair.
Okay, interesting. All right. We've covered a very hungry black hole and variable stars, and hopefully we know a little bit more about... I've thought of another question, Fred. I don't know if anyone would think of this offhand, but do we know... No, let me rephrase. How many black holes are we aware of? I know we've now got a photograph of one, but how many are we aware of?
Yeah, so... In terms of what are called stellar mass black holes, I was writing about this quite recently in the new book, so I've got the figures. I think we've got something like 30 that are catalogued, and they're all catalogued because of their effect on their surroundings, usually because of a binary system, a double object system like we've just been talking about. But they're all in our own galaxy. However, there are probably millions of them in the galaxy, in fact. When it comes to the gigantic ones, the supermassive black holes at the centres of galaxies, I think the catalogue is round about 70. But probably all galaxies have them, a supermassive black hole at their centre. And we estimate that there are 2 trillion galaxies in the observable universe. So there's probably quite a few.
That's a lot of nothing. Okay.
Yeah, that's right.
All right. You're listening to Space Nuts with Andrew Dunkley and, of course, Professor Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/nuts. space. That's TRYEXPRESSVPN.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, before we move on to the moon creation theory, you're on a little bit of a sojourn at the moment. Well, it's a working sojourn.
It is, yeah. It's it's very, very busy, but it's brilliant stuff. So I'm at a conference in Kuala Lumpur in Malaysia at the moment. It's a week long, and I won't ask you to guess what kind of conference it is because you'd never get it. It's the annual scientific meeting of the Australian and New Zealand College of Anaesthetists.
Oh, right.
There are 2,000 anaesthetists here in Kuala Lumpur.
And everyone's asleep. As happens at conferences.
Well, the thing is, they can put themselves to sleep. Yeah. So what they did, and this has been in my diary for 2 years, and it's a real privilege to be here. They decided to theme their conference at this year's conference on space medicine, and so there are some amazing people here, but they also wanted an astronomer to, talk about things like Mars and space travel and all that sort of stuff. So I was asked to do 5 talks. I've done 4 of them. As soon as you and I have finished, I'm going to get to work on preparing the 5th, which is actually the closing talk of the conference. So no pressure, but I'm hoping to inspire these 2,000 people to think big. What has inspired me, though, is there's a number of space medical specialists here, including people from NASA, who are very well versed, of course, in how you look after astronauts. And there is indeed an astronaut, Michael Barrett, who has flown twice to the International Space Station. He's not just an astronaut, he's also a doctor. And so he can talk very knowledgeably about, space medicine, and in fact practices it when he's on board the space station. He's the station doctor. Mm-hmm. So look, it's been an absolute privilege to meet these people and interact with them. And it's lovely to find folk who's, you speak the same language as them, because I tend to spend half my life in space anyway, not physically, but certainly mentally. So I'm thrilled to have been able to contribute to the conference, and it's been a great pleasure to be here. It's a bad time because I've got so much else going on at the moment. I expected I'd be able to do stuff while the conference was on because I don't know anything about anaesthetics, but all the talks have been so interesting. I talk about sustainability in anaesthesia, things of that sort, marvellous stuff. So it's been a very, very good conference.
It also reminds me that a while back we got a question from one of our audience members about becoming a NASA doctor. So that would obviously very much interest them. Yeah, fascinating.
I should just mention, Andrew, that it is Space Nuts, the podcast, that got me this gig in the first place.
Seriously?
Yeah, because one of the leading figures in this conference, Lorna Workman, I met her a couple of years ago, and she told me that Space Nuts got her through her anaesthesia degree examinations. So we are useful after all. I'm sure we have to forget.
I'm sure it's something I said.
Maybe it was you. Yeah. No. Anyway, she was very happy to be a Space Nuts fan. I don't think she is anymore. I think she's probably grown out of it. Maybe just too busy or something like that. No, she did tell me she told me she stores them up to listen to. So that's quite nice. So thank you, Space Nuts, for getting me this gig.
Fantastic. We're very popular with airline pilots too, as it turns out.
Yeah, we might get some free air travel as well.
Working on it. Now, let's get to this new theory about how the moon was created. What's this all about?
Well, this is such great news, and unfortunately, it came just a few hours too late for me to incorporate it into my talk on the origin of the moon, which I did here on Tuesday. So the best theory we have for the origin of the moon, and this goes back really to the Apollo era, is that very early in the Earth's history, within the first 100 million years, certainly, maybe even within the first 50 million years. And remember, the Earth is, like the rest of the solar system, is 4.6 billion years old. Very early in the Earth's history, the Earth suffered a collision with an object about the size of Mars. And we're so confident with this view of the origin of the moon that actually that colliding object has a name. It's been called Theia, which in mythology is the mother of Selene, the moon. So it's a very nice link. So Theia, about the size of Mars, bashed into the Earth, raised a cloud of debris, which accreted, came together, stuck together under gravity, eventually to form the moon. So it started off with this Earth that's been pretty well bashed up, with a disk of material around it, which has been thrown up by the collision, and from that the moon forms. The problem with that is, once again, something that we learned from the Apollo missions. What the Apollo missions taught us, the astronauts brought back 382 kilograms of lunar soil and rock. And those materials, apart from the fact that they're different, that the soil is different from earthly soil because it's all got sharp edges rather than being rounded by erosion as the particles of Earth soil has. So the particles are different, but chemically it's the same. And in particular, there's something called the oxygen isotope ratio. Chemicals come with different isotopes which correspond to different numbers of neutrons in their nuclei. And the oxygen isotope ratio for moon rock and Earth rock is identical. And what that tells you is that it is extremely unlikely that the moon's material came from anywhere else other than the Earth. But the problem with the Theia hypothesis is that if something bashes into the Earth and you've got this cloud of debris raised, which forms the moon, most of the cloud is made up of material from Theia itself. And the odds of that being identical to the Earth are very, very low indeed. So, excuse me, so there have been all kinds of dynamical arguments about, maybe it was, people have looked at glancing collisions, and it turns out that maybe that would give you more of the Theia material the Earth's material in the moon than Theia material. They've looked at the opposite, which is, head-on direct collisions very deep into the Earth's inner material. And that too would give you some Earth-like material in orbit to form the moon. But they've all got inadequacies, those. None of them are very straightforward, because you've got to tinker around with things like the total spin of the system and things of that sort. So this new theory, which has come from Yale University, it's I think it's a Japanese-born scientist who has done the work with colleagues in Japan. I think it's a joint US-Japanese project. They've built a model that says, okay, what if the young Earth was still covered by a sea of molten rock, molten magma, right, that it's still so hot that the rocks on it are liquid. That would have been the case about 50 million years after the solar system formed. So it's still pretty early in the solar system. So you've got this, this hot and melted Earth, molten Earth. But then you hit it with something that's much smaller. And because it's smaller, it's actually cooled so that the surface is solid. And if you do that, apparently what you get is exactly what the moon is like. I think this is a theory that really goes a long way towards improving our understanding of the formation of the moon. And it ties in with some of the other aspects of the moon that we know about. So a very hot Earth is probably one reason why the moon's crust on the Earth side is thinner than the Earth's crust on the far side. Because if the Earth was still very hot when the moon had been locked into this, what's called tidal locking, where the moon's always facing the same face towards the Earth, if the Earth was still very hot, there would be significant radiant heat falling on the early moon. At that stage, it was only, I think it's about 40,000 kilometers away from the Earth. It was very, very close. It was sort of distance that the geostationary satellites are. And that radiant heat actually chemically affects the surface and makes it easier for rocks to build on the far side, which is why the crust is thicker on the far side. So this ties in very much with what we know about the morphology of the moon, and gives you a really good model for how the moon formed with most of the proto-Earth materials.
So it was a molten Earth struck by a solid object.
Yeah, or an object with a solid surface.
Yeah. Now, are they suggesting that solid object, or the object with a solid surface, is the moon with an Earth coating, or it just sped off into space somewhere?
No. So it's still, it probably disintegrated itself, and it may well have been on a trajectory that took it. You know, the bits of that are probably still lurking in the asteroid belt somewhere, because they've been shepherded by the gravity of Jupiter. But the bottom line is that with a collision like that, the material that you throw up into orbit around the Earth is mostly Earth material rather than Theia material.
Okay. But if they were to do enough sniffing around, they might find Theia material on the moon.
That's right. Let me just read a comment by the lead author, whose name I'm about to mispronounce. It is Sonichiro Karato, and he comments: in our model, about 80% of the moon is made of proto-Earth materials. Proto-Earth is the young Earth. In most of the previous models, about 80% of the moon is made of the impactor, that's Theia. And this is a big difference. It absolutely is. And it seems to, provide a very neat solution to the problem. And it's very timely. It wasn't soon enough for me to get into my talk on Tuesday about the origin of the moon, but it's soon enough for me to get into my new book.
Excellent. Oh, very good.
Yeah.
Okay, so looks like the theory as to how the moon was created has a new element to it that, looks like it's got a lot going for it. So
that's true.
There might be more to talk about down the track. This is Space Nuts, Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, before we nail a couple of questions, a couple of announcements. We have a YouTube channel, which is very exciting. If you do a search in YouTube for Space Nuts Podcast, you should be able to find us. I think all 151 episodes are on YouTube. So I think 2 people have actually listened to the whole lot. Oh, no, they only listen to 1. But, and that's all that they could handle.
That's you and Judy, is it?
Yeah, well, that's about right. But yeah, we've got a YouTube channel, so check it out if you're a YouTube user. The other thing that's happened is this has actually come from audience requests. We've had a few people contact us saying, how do I donate to Space Nuts? Because, I'd like you guys to get a couple of dollars for what you do. And I didn't have a clue how to do this, so I took it to our producer and he said, I'll check it out. Well, he has, and he has set up a Patreon page for Space Nuts. So you can now go to a website called Patreon, patreon.com/Space Nuts, and you can become a patron of the Space Nuts podcast if you so desire. It's not essential, but we will be sending several thousand invoices very, very soon. But no, there's an option for you if you want to become a patron of Space Nuts, which is lovely. Now, Fred, we've got a question here from Jerry Stone. Hi, lads. I feel like I should be doing that with a Scottish accent.
Hey, lads, that's right.
Yeah, love the show. Nutty and entertaining, but great insight from the professor. Can't wait for Thursdays to come around. Quick question. What's your view on Stephen Hawking's parting advice to not seek out alien societies, or we might live to regret it, or not live, as the case may be? Hi to Mandu. Cheers from Gary at Manly West. Go the Sea Eagles, by the way, Gary.
Yeah, I think it's Jerry, actually.
Jerry, is it? Oh, it is too. I've got new glasses. It's my new glasses.
Hi, Jerry.
I was looking through the foggy part.
You have
Sorry,
to
Jerry. But still, go the Sea Eagles.
Go the Sea Eagles, that's right. I don't think that'll mean much to many of our listeners, but certainly doesn't mean much to me, I can tell you. Okay, a good question. And so what's my view on it? I think it's absolutely right. First of all, we're not actively seeking out alien civilizations. We've done a few things. Once in a while, we've beamed signals to test out new radio telescopes and sent them off to some place where there might be other planets. We've got 5 spacecraft leaving the solar system with little tokens of humanity on them. But what gives us away, really, is the radio noise that the planet makes because of all the radio communications. We're easily detectable by anybody with the same advanced technology that we've got. So Hawking's advice is predicated on the point, which is very well made, that normally interactions with, what you might call a more advanced species do not have a good outcome for the species who are being prevailed upon, if I can put it that way. And you've only got to think of what
human
we've
history.
done. The animal kingdom on the planet and human history, of course. As I think Stephen was quoted as saying, the exploration of North America by Christopher Columbus didn't have a good outcome for the indigenous population. That's exactly true, and we are now all desperately aware of that, and look with regret on the past and wish we had behaved differently.
And the same can be said for Australia. The same can be said for South America.
Yeah, that's exactly right. The whole world. Yeah. So the point is based on that theme, and it's very well made because the track record for advanced species is not good. I've got a slightly different take on that though, and you and I have spoken about this before, and that is the growing view among astrobiologists that species like us are probably incredibly rare, which makes things a bit lonely for us, but it does solve the problem. If there's nobody out there, they're not going to eat us. We've got different issues to deal with in terms of the longevity of humanity, but aliens is probably not one of them, because first of all, the distances are huge, but the statistics of life advancing or evolving to species like ourselves, they're not really in our favour. I think we have bucked the trend. We are simply probably or possibly freaks in the universe. We're something that has evolved in the universe that was probably very unexpected by whoever put the universe there. Yeah. Oh, look what's happened.
Yeah, we're definitely freaks. I'll agree with that.
Yeah, especially here on Space Nuts. But so it's good advice, but we're not really doing it. We're not beaming stuff out into space other than the inadvertent leakage of radio waves, which is pretty inevitable.
And they dissipate within 50 light years anyway, so beyond that, we're safe.
Yeah.
Yeah. And it brings up an interesting point, Fred. My new science fiction novel that I'm currently writing is based on the premise that one species does discover another, and all hell breaks loose.
Good,
more or less.
Well, we might need that as the handbook.
So I'm trying to think of a title, but I might call it The Hawking Warning. I don't know.
Ooh.
Could be worth it. I've got no title. I can't think what to call it yet, but it's early days and I've got a lot of writing to do. Now, moving on, we've got not so much a question, but an observation by Michael Davidson. Oh, thanks for your question, by the way, Jerry. Michael Davidson says a podcast that he's listened to, No Such Thing as Fish, it's called, by QILs, had an article about collecting spider silk for crosshairs for telescopes to pinpoint stars. Very interesting. Now, you know about this.
I do, yeah. Because very early in my career, I worked for the Royal Greenwich Observatory, which was Britain's national, or England's national observatory. Scotland also had a national observatory. I've worked at both of them. But by the time I was there in the early 1970s, the Royal Greenwich Observatory wasn't in Greenwich. It moved after the Second World War to a place called Herstmonceux in Sussex, in the south of England. And, of course, that was to get away from the encroaching city lights of London. They went to a dark place 50 miles away. a bit more than 50 miles, actually. It's probably more like, 70 or something like that. But deepest Sussex was where the Royal Greenwich Observatory was. And guess what? In deepest Sussex, among the hedgerows, you find perfect spider webs for making telescope crosshairs. Why do you use spider webs? Because they're beautifully uniform and, very fine. They're just fine strands of silk, which have incredible uniformity. And when you put them in the eyepiece of a telescope, which of course magnifies them, they give you exactly what you want, a crosshair in the field of view. And whilst by the 1970s, and I should even say the 1950s, because that's when the move to Hurstmonceux took place, photographic techniques were what everybody used for recording images of deep space. There was a section of the observatory which was all about the rotation of the Earth. And special kinds of telescopes were used, what they call transit telescopes or meridian telescopes. They move only in one plane, and they're exactly in the north-south plane, and they time stars as they go past as the Earth rotates. And to do that, you need crosshairs. And guess what? They used spider silk for that. That's why even in the 1950s and 60s, astronomers from the Royal Greenwich Observatory went out in the hedgerows of deepest Sussex looking for spider webs.
Isn't that amazing? I would never have made that connection.
No, that's right.
Yeah, that's awesome. I could use some spider web right now because on cue, I'm being hassled by a blasted
I could see
fly.
it.
Did you see that?
Your nose.
He just flew past the front of the camera. Go away. We've had some work done at the house, and of course the doors were open for lengthy periods, and because we've had an Indian summer, the flies are still around. Usually they're gone by this time of year because it's too cold, but I'll get this one. You're gone, sunshine. I'll deal with you in a moment. But first, before we do that, we have to deal with one more question. I was looking forward to this question, which is why it's last. This comes from Bill Bullimore. Hello, Bill. And he says, hi, Andrew and the Professor. Reminds me of a movie. In fact, that's what he's talking about. I just wanted to know why so many scientists hate the movie Gravity. I know it's all very unlikely physics, but the premise of the movie is not to perfectly explain space science, but to examine the human spirit. If nothing else, isn't this what all this questioning is about? Look, this movie I have seen a couple of times and I thoroughly enjoyed it. George Clooney and Sandra Bullock. And it's basically about some people who are working on a space shuttle, and I think they're working on a satellite or something to that effect, or a space station, and they basically get caught in a massive orbiting debris which obliterates their spaceship and the satellite. And it's all about trying to survive. And yes, I from my standpoint, I agree with Bill. The science in it is questionable, but the story is more about doing what you need to do to survive.
Yeah, exactly. So, in fact, I can concur with all of that, Andrew. I certainly didn't hate Gravity. I thought it was a pretty good movie. The basic premise that there is so much space debris up there and it's a risk to human spaceflight, that is right on the money. They routinely steer
especially after what India did the other day.
Well, that's exactly right. Yeah, that's right. That's very sad. The basic. Well, I was about to say that often on the International Space Station, the space station's orbit is changed slightly when the ephemeris, that's to say the schedule of things going around in orbit around the Earth, as that schedule shows up things that might conceivably collide with the space station, and this is the known debris, of which there's sort of 25 or 30,000 bits tracked, they move the space station out of the way. So it's absolutely real possibility. And some of the, I think the depiction is really well done of how you deal with it's not zero gravity, it's free fall. You're actually under the Earth's gravity, but because you're moving horizontally so fast, you never fall towards the Earth. So that, I think, was all very well portrayed. The bits where it becomes fiction rather than fact are the things that you can easily excuse being altered in the story, and that is the proximity of various different bits of space hardware. For example, I think Chinese space station in it, which happened to be in effectively the same orbit as the space station that these guys were working on. There was something else lurking around. It's just simply not like that in space. These things are all in different orbits. They're thousands and sometimes tens of thousands of kilometers apart. So you couldn't just trip from one to another. But I was perfectly happy with that. I don't have any problem with that. It's a movie, and it's depicting something that really reflects, as Bill said, the human spirit. Yeah. So I give it a tick. I think it's great. I think, if I remember rightly, there was a bit of stretching of the imagination towards the end as to how Sandra Bullock got back to Earth. I can't remember the plot exactly.
She had to leave. I think she had to leave one spaceship to get to another. So yeah. I think she ended up being in 3 different capsules or something, but she had to get from one to the other with a fire extinguisher or something. I think it was.
Yeah. But it was I think it was the re-entry was, if I remember rightly, was reasonably well portrayed. All of that stuff. So it's great stuff.
But they can criticise Gravity for using that fire extinguisher propulsion system or whatever it was she used to get from one spaceship to the other, as ridiculous. But they did it in Mission to Mars as well. No, they did it in the Martian, where he left the capsule to join his mothership by poking a hole in his suit and using that as propulsion. They did that in both films.
Yeah, so that's fine. The trouble is with that, the reality of that is, unless you are exactly lined up with your centre of mass, all it'll do is set you spinning.
Yeah.
And that exact alignment is something, well, I personally wouldn't like to try and risk it, I have to say.
Absolutely not, no. But don't let the truth get in the way of a good story, as a famous journalist once said.
The principle's good. Good.
Yeah, but it's still a great film, very entertaining, and, we won't spoil it by telling you how it ended, but they all die. No, they don't.
Righto.
All right. Thank you so much, Bill, for your question, and everybody who sent in questions. We'll work our way through the long list over the coming weeks on Space Nuts. And thank you, as always, Fred. Enjoy the heady days of conferencing in Kuala Lumpur, or Lumpy Koalas, as I like to call it. And we will hopefully have you back next week.
Sounds good, Andrew. Thank you very much. Good to talk to you, and speak soon. Get that fly now.
Yeah, his minutes are numbered. I am so good with a tea towel. Yeah. All right. See you, Fred. Fred Watson, and he's an astronomer, Professor Fred Watson. And from me, Andrew Dunkley, thank you again for your support, and we will look forward to catching you next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.